Gauss law is about electric flux and electric charge. It is relating electric flux represented with psi e, electric flux, and electric charge represented with q. And it is related to closed surface. Closed surface. So closed surface is nothing but we can consider it is volume. Closed line is open surface, closed surface is volume. So these are the things we have to remember when we discuss about the Gauss law. So it is relating electric flux and electric charge. That the charge is available in this particular closed surface and electric flux is passing through the closed surface. Okay, this is the terminology we are using. For example, this is the closed surface we have taken, and it is not open surface, it is closed surface. Like that you have to understand. For example, here plus 5 microcoulombs amount of charge is there. Charge and electric flux both are measured in coulombs only. Both are measured in coulombs only. So what is there inside the closed surface? That is 5 microcoulombs amount of charge. So q is equal to 5 microcoulombs I have given. So same amount of electric flux will be going out of this particular closed surface. That means generally electric flux lines will be like this. Because it is a positive charge, all the flux lines are going outside only. So whatever the amount of electric flux which is passing through this particular closed surface is again equal to 5 microcoulombs only. That itself is Gauss law. So what it is telling means within the closed surface, if you keep q coulombs of charge, then its equivalent amount of electric flux psi e will be passing through that particular closed surface. Okay, that is the Gauss law. In this way, we can able to define. So particularly the electric flux passing through any closed surface. Why it is passing? Why can't we take leaving or why can't we take entering means? If you take negative charge, the flux lines will be entering into the closed surface. If you take positive charge, flux lines are leaving the closed surface. So for the commonality purpose, we can able to take the definition like this. That is, the net electric flux which is passing through any closed surface is equal to the total charge which is enclosed by that particular closed surface. So this is the statement for the Gauss law. In this manner we can take. Afterwards, we'll change the form of this particular Coulomb's law. Sorry, Gauss law. We can write this electric flux in terms of the electric flux density d bar. D bar is the electric flux density which is measured in coulombs per meter square. Through this particular total surface, for example, if you imagine one room is there, within that particular room, if you keep 6 coulombs of charge, 6 coulombs of charge has been kept inside the room. Okay, and the room is having 6 surfaces. And if you assume that room is in the cubical shape, that means all the 6 surfaces are of same dimensions. Okay, and inside the room, that means inside the volume, that means inside the closed surface, how much amount of charge is there? 6 coulombs of charge is there. So how much amount of electric flux can able to leave from that particular closed room through the 6 surfaces means 6 coulombs of electric flux only. So you see the terminology, electric charge measured in coulombs, electric flux is also measured in coulombs. So how much amount of charge is there within the volume or closed surface, same amount of electric flux will be leaving the closed surface. So like this we can able to take 6 coulombs of electric flux will be leaving that particular closed surface. In order to understand this one, we are talking in terms of the electric flux density d bar. For example, each wall of that particular room is 1 meter square. Okay, that means total surface area of that particular closed room is 6 meter square. Because 6 surfaces are there, each surface area is 1 meter square. So total surface area is 6 meter square. Okay, and I said that 6 coulombs of charge is there within the room. Okay, then because that is there in the cubical manner, the total amount of electric flux which is leaving through the all 6 surfaces is 6 coulombs only. That means through each surface, how much amount of electric flux will be leaving means 1 coulomb. So through this particular surface 1 coulomb will be leaving, through this particular surface 1 coulomb will be leaving, like that through the 6 surfaces 1 coulomb, 1 coulomb, 1 coulomb, like that 6 coulombs amount of electric flux will be leaving. Okay, now coming to this D bar, this D bar is giving the information about not complete electric flux which is leaving through the 6 surfaces. Okay, it will give the electric flux only. It will give the electric flux which is passing through 1 meter square surface area. Okay, so it is for 1 meter square. Per unit area, how much amount of flux is there, that is given by this particular D bar. So D bar is giving the information about 1 unit area only. So if you multiply this D bar with the total area, then you will get the total amount of flux which is leaving through that particular 6 surfaces. Okay, that is what we are following here. So this left side part, whatever the electric flux is there, that one we can write in terms of the electric flux density. How we are writing, you see, D bar is giving the electric flux per meter square. So when you want to multiply with the differential area, it will give coulombs, because the differential area is also measured in meter square. So coulombs, meter square will be cancelled, means this product is actually giving the electric flux only, that is in coulombs. But it is not complete electric flux which is passing through the total closed surface. So what we need to do? We need to do here closed surface integral of d bar dot ds bar. This integral, we can get the electric flux which is passing through the total surface area. Okay. So instead of this psi e, now we can write a closed surface integral of d bar dot ds bar. If it is closed, then only that is Gauss law. If it is open surface integral, that we cannot be the Gauss law. Okay, so this is about the left side part, and right side part people will write q enclosed only. This is another form of the Gauss law. This is another form of the Gauss law. Next, this q right side part we will talk now. Closed surface integral of t bar dot ds bar is equal to q enclosed. So within the closed surface, you may be having point charges like q, you may be having line charges having rho l, you may be having surface charges having the surface charge density rho s, or you may be having volume charges with the volume charge density rho v. The combination of any of all the any of these things will be possible. You may have only point charges, you may have only line charges, or you may be having the combination of these things also. Okay, so this right side part Q enclosed is actually giving the total charge available within that particular closed surface. So if you are dealing with point charges, Q is enough. But if you are dealing with the line charges, then how to write total charge? We know from the line charge concept, that is dq is equal to rho l dl. You can check with the units. Rho l is in the units of coulombs per meter, dl is in meter, meter will be cancelled, you will get a q, dq. To get the total charge, you have to integrate that one. So this right side part you can write line integral of rho l dl, you can write. If it is a surface charge is available, surface integral of rho s ds you can write. Or if it is volume charge, you need to write volume integral of rho v dv. Like this you can write anything. Or if it is just point charge, you can keep a q also. But whatever it may be, this integral rho l dl, integral rho s ds, integral rho v dv will give the charge only. Okay, in coulombs only we will get. That is what we have to take as the Gauss law. Okay, so because we are working with the closed surface, we can consider now this closed surface will go volume, so that this d bar dot ds bar is equal to, we will write here volume integral. We'll see what will happen if you equate these two. Okay, now if you observe left side, we have the closed surface integral, right side volume integral is there. So using this Gauss divergence theorem, we can convert closed surface integral into volume integral. Okay, so this Gauss divergence theorem here I am writing. For example, you have the closed surface integral for one vector a bar. Okay, closed surface will give volume so that you can remember that it can be equated to volume integral. But when you write the volume integral for this vector A, you need to take the divergence. That is del dot A bar you have to take, because it is volume integral, you can write here dV. And what is this Stokes theorem is nothing but Stokes theorem will give the information that the closed line will give the open surface. Closed line will give open surface. That concept we have to take. Okay. So this Stokes theorem can be written like this. Closed line integral of, for example, same A bar if you take, closed line integral of A bar dot dl bar is equal to open surface integral of. Now instead of taking the divergence, now for the vector A bar, we have to take curl. So del cross A bar, because it is surface integral, we have to write ds. Okay. So this Stokes theorem will be used later. Now for the time being, we can able to use this Gauss divergence theorem. Why? Since we are dealing with here closed surface integral. So this closed surface integral now can be written as the volume integral of this particular divergence of the d bar. For d bar, actually closed surface integral is there. Because we are writing now volume integral, we can take this one divergence of d bar. Because it is volume integral, now it become dv. Okay, and it is equal to volume integral of rho v dv. Take this volume integral of rho v dv to the left side, then you can take common volume integral. So you will be leaving with del dot d bar is equal to rho v. So this is the point form of the Gauss law. Okay, or differential form of the Gauss law. Okay, this is important generally for the examinations. Okay, del dot d bar is equal to rho v. It is a point form, and we can take this is the integral form, either this one or this one also we can able to consider as the integral form. Okay, there. So just now I told about this one, all the equations I will write at one place. Generally Gauss law means you can start like this. Okay, net electric flux passing through any closed surface is equal to charge enclosed by that closed surface. Like this, this itself is given the Gauss law. Afterwards, just we are changing the form. This electric flux we are writing in terms of the electric flux density. Closed surface integral of d bar dot ds bar is equal to q enclosed. Or you can write line integral of rho l dl, or surface integral of rho s ds, or volume integral of rho v dv. Okay, so this can be considered as the integral form of the Gauss law. Next point form means just now we got del dot d bar is equal to rho v. So in the problems, whenever d bar has been given, if you want to find the charge density, or if you want to find the charge also, what you need to do in the sense, you can apply this divergence, this particular point form of the Gauss. That means divergence of d bar is equal to rho v. Okay. If you use this one, the problem can be done very easily, because calculating the divergence is simple compared to this integral formulas. Okay, so just I will write here divergence formula. Delta d bar is equal to 1 by h1 h2 h3 dou by dou u, and here's h2 h3 du. That means first component of the d bar, plus dou by dou v. Here we can write h1 h3 dv, second component of the d bar, plus dou by dou w h1 h2 dw. Like this we can write the formula for the divergence. It depends upon the coordinate system. You can select h1 h2 h3 and u v w accordingly. Okay, for example, Cartesian coordinate system, if you take h1 h2 h3 will become 1 1 1, and u v w can be taken as the xyz. Okay, in case of the cylindrical coordinate system, h1, h2, h3 can be taken by 1 rho 1, and uvw can be taken by rho phi z. And in case of the spherical coordinate system, h1, h2, h3 can be taken by 1 r sin theta, and uvw are given by r theta phi. So in any coordinate system, we can use this particular formula for the divergence. Based upon the problem given, you need to choose the related correct formula. Okay, then uh, now this particular problem is based upon the Gauss law only. So if you know the concept, you can able to solve this particular problem. Here we have given 3 point charges. Q1 is 30 nanocoulomb, Q2 is 150 nanocoulomb, and Q3 is minus 70 nanocoulomb. are enclosed by the surface S. What net flux crosses through the S? Actually, it is a closed surface. For example, if you take this is a closed surface S, they have given Q1 is available and Q2 is available and Q3 is available. So just by the definition of the Gauss law, we can solve this one. What is Gauss law? Net electric flux passed through any closed surface is equal to charge enclosed by that particular closed surface. But here three charges are there. So just you add all those charges, Q1 plus Q2 plus Q3. So it is equal to Q1 is 30 nano, Q2 is 150 nano, and Q3 is minus 70 nano. So it is equal to how much you will get. 150 minus 70 is 80, 80 plus 30 is 110. All are in nano coulombs. So this is the answer. That's it. Okay. So this particular problem is based upon the statement of the Gauss law. Psi is equal to Q. That's it. Next question. If Q coulombs is kept at the center of the cube of 5 meters each side, then 5 meters is each side and Q coulombs they have kept. Then what is the amount of flux passing through any one surface of the cube? This one already I have explained. So cube means all the surfaces are of same dimension. So like this, if you take 6 surfaces are there, at the center we have kept 2 coulombs of charge. So that means how much amount of electric flux will be passing through all the 6 surfaces. All the 6 surfaces, if you consider, that must be equal to Q only. Okay, total net electric flux passing is equal to Q only. But here this particular cube is having six surfaces. So through each surface, how much amount of flux is passing? Okay, through each surface, this is Gauss law. Now we are analyzing that one. Through each surface, how much amount of flux is passing means Q by 6. Because 6 surfaces are there, Q by 6 into 6 means again you should get Q. So this is the answer. Okay, through one surface, how much amount of flux is passing? Q by 6. If I ask through two surfaces, how much amount of flux is passing? 2 Q by 6. Okay, 2 times of Q by 6. 3 surfaces means 3 times of Q by 6. Like that, 6 surfaces means 6 times of Q by 6, that is equal to Q. That is nothing but total closed surface or the volume. Like that we can able to do. Next, a circular disc of radius 4 meters, okay, with a charge density rho s is equal to 12 sin phi microcoulombs per meter square. So circular disc means already in module 1 we have taken the electric field calculation due to the circular disc. At that time we used rho s only, because circular disc means it is a surface, okay, not a ring. Circular ring is different from the circular disc. Circular disc is having the surface charge density, circular ring is having the line charge density. Okay, anyhow, this particular surface circular disc is having radius is 4 meters and having certain surface charge density. Surface charge density is equal to 12 sin phi microcoulombs per meter square. Okay, is enclosed by certain surface. So it is enclosed by certain surface. That is closed surface. What net flux causes the S? That is the question. Okay. Comment on the flux value obtained. Okay. So actually, if you observe the Gauss law, they asked about psi net passing through the closed surface is equal to, according to Gauss law, we can equate this one to Q enclosed. But in this particular problem, they did not give Q directly. They did not give Q directly. They have given rho s, so that this Q can be written as surface integral of rho s ds. So this is what we need to do here. Okay, so it is equal to integral. This is the circular disc. Okay, circular disc means it is formed because of the changes in R and this. Sorry, it is in the, we can take cylindrical coordinates, so it is due to rho and phi. It is due to rho and phi. Due to the changes in rho, how can we tell? This is a dot, this is the circle we got because of the radius is rho. We increase the rho value, we increase the rho value, we increase the rho value. So like that, this particular this particular surface has been created. This particular surface has been created. That means rho is variable, and we are moving around this one means phi is also variable. So surface has been created because of the changes in rho and phi. So what is ds now? Because of the changes in rho, d rho, and because of the changes in phi, rho d phi. These are the differential length along rho direction, differential length along the phi direction. So differential surface is the product of these things. So now we can write rho s into ds is rho d phi. Like this we can able to take. Okay. So uh, they have given 4 meters. So that means rho range is from 0 to 4. So rho is equal to 0 to 4, and rho s they have given 12. I'm writing outside sine phi, and rho is okay, rho is I have written rho is a variable, so rho is to be kept inside only. Rho d rho is variable, d phi is variable, so it is equal to 12 integral rho d rho and integral phi, that means sine phi d phi. Okay, so rho changes from 0 to 4. Here surface integral means here phi is also changing from 0 to 2 pi. So phi is equal to 0 to 2 pi. So you concentrate on this last integral. Okay, what is the integral of sine phi? Cos phi. Okay, or minus cos phi, whatever it may be, minus cos phi. If you substitute the limits, you will get 1 minus 1 means this will become 0. 0 into something is 0. That means total charge, that means total charge you got now 0. If total charge is 0, total net flux which is passing is also equal to 0. So no flux is going out of this particular closed surface. That is the answer. Okay, 0 amount of flux, 0 coulombs of electric flux is passing through the closed surface. How it is possible? They said that within the closed surface you have the circular disk having surface charge density. Okay, surface charge density is there means charge is there, charge is available. Even though charge is available inside the closed surface, no flux is going outside. How it is possible means equal amount of positive and negative charges are available. Charge is there, positive charge is there, negative charge is there. So total charge is equal to 0. Because of that one only, no flux is going outside. Okay, so this is the dipole concept. Okay, when you have plus q and equal amount of one opposite charge we have to take, plus q and minus q, this combination is called dipole. Okay, so based upon the dipole concept we can able to tell no flux is leaving the closed surface. That is the thing. Then next question is based upon the work done actually. So work done concept first I will tell. Quickly we will complete this one. See carefully. For example, this is a jet, this is X. We assume that one uniform electric field is available like this. It is downwards and it is uniform, that means constant. So electric field E bar is equal to, we can take now because it is constant, just I'm equating to one E naught, one number, and its orientation is a negative X direction. Like this we have taken. Okay, positive x direction is upside, negative x direction means downside. So it is equal to minus E naught x cap. Like this we have taken. Okay, then this is E bar minus E naught into x cap. Now if you have one charge here, okay, this is at the level of x1, we have to move the charge up to x2. This is the work we have to do actually. Okay, so first you assume that this electric field is there in the negative x direction, that is given by minus E naught into x cap, and charge q is available at the height of this x1. Okay, so on the charge q, certain force will be there due to this electrostatic field. Okay, E bar is the electric field, that is electrostatic field. Because of that one, we know the relation between electric field and force, that is charge times electric field. So what is the charge now? Q. What is electric field? E bar. So it is equal to, we can able to take minus Q times of E naught into x cap. Like this we can able to take. Okay, this is the force available on the Q due to this particular electric field E bar. We have force on the charge. Okay, that is minus q e naught times of x naught. So in which direction e bar is there, in the same direction electrostatic force is also there. Okay, now we are increasing the concept now. Okay, we are entering into the work done concept. Till here you have to be very careful. Okay, work actually already one existing electric field is there, that is downwards, and due to that electric field some force is exerted on that particular charge q, and because charge q is positive, okay, electric field direction and electrostatic force direction both are in the same direction. You can see negative x direction only. But work is nothing but work can be said that work can be done whenever the movement of the charge is occurring opposite to the already existing field. Okay, in which direction existing field is there, for that particular existing field the charge is to be moved oppositely, then only we can say work has been done. So now the charge is to be moved opposite way, means towards positive x direction the charge is to be moved up to the level of x2. Okay, along the x direction only it is moving, but from x1 to x2. Okay, and opposite to the already existing field is downside, so we are moving opposite way. Okay, so for that we have to apply force on the charge q. Okay, we have to apply force on the charge q, and this externally applied force must be opposite to already existing electrostatic force, then only we can say work has been done. So this is the concept of the work done. Okay, so then we can say work has been done on the charge q in order to move from x1 to x2. This is the theory. Now while coming to the mathematical equations, so work is said to be done, and that is equal to, for example, small amount of distance we have moved, so that small amount of work has been done. Work is equal to force into displacement, so force into dl. Okay, here external force is to be applied. Because of the external force only the charge has been moved. That's why in the work formula directly whenever you are writing F external is there, but F external is opposite to electrostatic force. Okay, that's a minus negative of this electrostatic force we have to take dot dl bar. Okay, so we can discuss this also. For example, if you are moving opposite to the electric field, what is the angle between these two? 180 degrees, like that we can take. Okay, so whenever it is 180 degrees, the cos function value will take the maximum value, where it is -1 or +1, maximum work can be done. But when you are traveling perpendicular to the already existing field, okay, perpendicular means like this, you are moving like this, but already existing field is like this, that means what is the angle? Theta is equal 90. Whenever it is 90, so the dot product will become 0, cos 90 is a 0. Okay, that means no work has been done. Okay, for that purpose only the dot is to be included. Okay, it is following the trigonometric function cos. Okay, so because of that reason we have to take the dot. Okay, then dw, then you can write a equation for the electrostatic force, that is q times of already existing field e bar dot dl. This is a differential work dw. Work is scalar. Okay, dot product result is a scalar. Now if you want to get total work, just you have to integrate that one. Work is equal to minus q times of integral e bar dot dl bar, like this we can take. Okay, for example, you are moving, in this particular example you are moving the charge from x1 to x2, you can keep like this. Okay, this is the way of then so this is the equation for the work. Now if you see the problem, they have given one electric field. They have given one electric field E bar is equal to 2x x cap minus 4y y cap. Then they are asking us to find the work done moving a point charge 2 coulombs. So Q is equal to 2 coulombs from 200 to 000, and then 0002 to 020. This is A bit. Then B bit is from 200 to 020 along the straight line path joining the 2 points. Okay, so if you observe on the coordinate system, xy we have taken. Okay, this coordinate systems we are taking 200 means that it is there on the x-axis, 200. From 200 we are moving to origin, and then from origin to 020. 020 is available on y-axis 020. Okay, so this is the path. This is the path 1, path 2. Okay, so if you observe this particular work equation, just we need to do the dot product between E bar and DL bar. E bar they have given, DL bar depends upon the path it will be changed. So your job is to get DL bar properly. Okay, after getting the DL bar, perform the dot product, then perform this integral. Okay, this integral x1 to x2 I have written depends upon this situation only. Okay, so it depends upon the situation, this integral limits will be changed. Okay, you have to be careful with that one. Then we have to multiply with the minus q, then the work done we can able to get. So now we have two paths. So I'm taking path 1 first. We can calculate the work as per pathways. Okay, so in the path 1 we are moving the charge from 0 to 0 to 0 0 0. So if you observe, no changes in the y coordinates, no changes in the z coordinates. There is change only in the x coordinate. That means dl bar is simply dx x cap. Okay, change is occurring in the x direction only. That is the meaning of this one. Okay, then immediately you can calculate e bar dot dl bar. E bar is having x component and y component, but dl bar is having only x component. So the dot product will give this 2x dx. X cap dot x cap is 1, y cap dot x cap is 0. That's why it will be giving 2x into dx. Then we have to do integral of this one. So integral from where to where, you see the path. Okay, charge is moving from x value 2 to x value 0. So according to the path you have to select the limits. So integral 2 to 0 e bar dot dl bar we have to perform. So that also I'm writing here, e bar dot dl bar is equal to integral 2 to 0 2x dx. It is equal to 2 constant. So x integration is x square by 2, limits are 0 and 2. So if you substitute you will get like this. Okay, so it is equal to minus 4 we got. Now work done equation is equal to minus q times of this integral e bar dot dl bar. So integral part already we have done. Minus q is 2 coulombs they have given, and integral value we got to minus 4. So it is equal to 8 joules of work has been done in order to move the charge from 2 to 2000 to this 000. Okay, so during the path 1 this much amount of work is required. Okay, similarly you can go for path 2. So in path 2 we are moving the charge from origin to 0 to 0. Okay, that means along the y-axis we are moving. Okay, so easily you can tell here we are moving from 0 0 0 to 0 to 0. That means here only y coordinate is changing. That means dl is equal to, or dl bar is equal to dy into y cap. And then e bar dot dl bar you can calculate. E bar is having y component minus 4y into dy we will get. Okay, so integral also you can do integral e bar dot dl bar, and this y coordinates are changing from 0 to 2. Okay, then integral 0 to 2 minus 4 by dy, it is equal to minus 4 y square by 2. If you substitute the limits you will get 4. It is equal to minus 8. Okay, then you calculate the work related to this particular path 2. So we have to multiply with minus q, that's it. Okay, so minus q times of integral e bar dot dl bar, that is equal to minus 2 times of minus 8, that is equal to 16 joules of work is required in order to move the charge from 0 to 0 to 0. That is the meaning of this one. Okay, so then a bit is actually from first path work and second path work. So if you consider this is a w2. Okay, in the previous case whatever we got, that is w1. Now this a bit is having the work that is from W1 plus W2, that is equal, previously we got 80, 8 plus 16 is equal to 24 joules of work is required in order to move the charge from 200 to 020. Okay, this is the way of doing this particular problem. Next, if you see the B bit, they asked us to move the charge from 0 to 0, sorry, 200 to 020. Okay, and if you observe the first path, that is 200 to 000, and then from here to 020. So this A bit to B bit, if you observe carefully, A bit and B bit, if you observe carefully, in the A bit we are moving from 2002, finally we are reaching the 020. In the B bit also same end points only. But here path is different. Okay, we have to move along the straight line path which is joining these two. That means graphically, if you observe, this is one point, this is another point. In the first case, in the bit A, we are moving like this. Okay, from 2002 we move to 000, then 020. This is the path we have followed in bit A. But now we have to follow along the straight line path. Then what will happen, that is what we have to see. So the straight line equation is required now. So 2 points are there, anyhow z coordinate is 0, so take it is x1 y1, it is x2 y2. Calculate the line equation. First you calculate the slope is equal to y2 minus y1 by x2 minus x1. So 0 minus 2 by 2 minus 0, that is slope is 1. So line equation can be given like this. So y is equal to mx plus c. So it is equal to m value we got minus 1, so minus x. Whenever x is 0, y coordinate is 2, so y is equal to minus x plus 2. This is the line equation. Okay, then what we can do now, we can start calculating the work. So we got y is equal to minus x plus 2, and our starting point is 0 2 0 0, ending point is 0 2 0. Okay, now our job is to get dl bar at first. Okay, to get dl bar, if you observe carefully, x is changing, y is also changing. So in this path, both coordinates are changing, x and y. So dl bar will be given by dx x cap and dy y cap. Both are required. Okay, then calculate e bar dot dl bar. E bar is having x component and y component. So corresponding x components, if you multiply 2x dx minus 4y dy, like this will get a e bar dot dl bar. Then integrate. So if you do integrate like this, we have to do integration is to be done for the x coordinates 2 to 0, for the y coordinates 0 to 2. You can say, you can observe that one. So it is equal to is constant, x integration is x square by 2, and units are 2 to 0 minus 4, y integration is y square by 2, and units are 0 to 2. So it is equal to 2 by 2 cancelling, 0 minus 4, and minus 2, 4 minus 0. So it is equal to minus 4, it is minus 8, that is equal to minus 12. Okay, it is not work done, it is just integral e bar dot dl bar. Work done is given by minus q times of integral e bar dot dl bar. So it is equal to minus 2 times of minus 12, that is equal to 24. So interestingly, what we got means, whether you are moving from 2002 000, and from here to 020, we have moved in this way. Okay, in the bit A, we got work is equal to 24 joules only. 8 plus 16 we got 8 joules to 16 joules. Now we are moving from 2002 to 020 along the straight line path. Here also we got 24 joules only. So what is the important point means here, in a electrostatics, work done is based on the end points only. Whether you are moving from 2002 to 020, these end points, where you have started, where you have ended, these end points are important, not the path, okay, in which the charge is moving. Whether you are moving like this, or whether you are moving directly along the straight line, that is not the matter. You can move like this also, you can move like this also, in any manner you can move, but the total work done depends on end points only. Okay, if it is possible like this, then that type of fields are called conservative fields. Conservative fields. So our electrostatic fields are conservative fields. Those are depends upon the end points only, not on the path. Okay, this is true for all the problems. Okay, so that is what you need to understand. Next, just extension to the previous thing, we said that whether we are moving like this or like this, we got the same work done. Now, instead of doing like that, in a different manner, we can think, that is, first you start here only. I will give the number, this A, B, C, D, A, B, C. Like this I have given. So, A to B, AB plus BC is equal to AC. This is what we got. Okay, that means work done. Work done in order to move the charge from A to B, and work done in order to move the charge from B to C. This total work is equal to work done in order to move the charge from A to C. Okay, that is what we observed in the previous problem. Instead of doing like this, now I am doing in a different manner. A to B and B to C. Okay, then C to A if you take like this, what will happen? A to C work done is 24 joules. A to C work done is 24 joules. So C to A will come as minus 24 joules. This is 8, this is 16 joules. So A to B means here also 8 joules will be there. B to C means here 16 joules will be there. But instead of taking A to C, I have taken C to A, that will become minus 24 joules. So now you see this path, A to B, B to C, C to A. Now you see the total work, what will happen? 8 joules, 16 joules, minus 24. Total work done is equal to 0. So that means what is the difference between this first case and second case means, in the first case end points are same. Okay, where you have started, that point is same in two paths. Where you have ended, that point is same in two paths. But here we can consider it is a single path only. Okay, in this case it is a single path only. Okay, you have started at A, then moved to B, then moved to C, then again you are coming to A. That means you are moving around the closed loop. Okay, you are moving around the closed loop. So when you move along the closed loop, W is equal to minus Q times of closed line integral I am taking. This is indicating that especially for the case 2. Okay, in case 1 you cannot take a closed loop. In case 2 only you can take closed loop. Okay, because you started at A, you ended at A. That's why closed loop. But in this case, what did you observe? Total work is equal to, you got 0. Okay, then you send this minus Q to the right side, then closed line integral of E bar dot dl bar is equal to, you got 0. Then apply Stokes theorem. Using the Stokes theorem, we can convert closed line integral into open surface integral. But we have to take a curl for E bar, ds bar is equal to 0, then del cross E bar is equal to 0. This itself is our KVL. Okay, KVL means what? The algebraic sum of all the voltage drops is equal to 0. Okay, E bar is measured in volts per meter, DL is in meter, meter will be cancelled. You are adding all the voltages in a closed loop. That will become 0, that itself is KVL. Okay, so it's a curl equation is giving the 0. So electrostatic fields are having a divergence nature, not curly nature. Okay, so whenever curl is 0, we can able to tell that electrostatic fields are irrotational in nature. Irrotational in nature. Those are having a divergence nature. If for some fields divergence is 0, then those are called solenoidal. Find the work done in moving a point charge 5 microcoulombs from origin to this is spherical coordinate G 2 pi by 4 pi by 2. As it is given in spherical coordinates, we can take r is equal to 2 and theta is equal to pi by 4, phi is equal to pi by 2. Okay, so in the previous problem we have worked on the Cartesian coordinates. Okay, 2 0 0 2 0 0 0 and then 0 2 0, like that we have taken, so it is simple. But in this case we have taken spherical coordinates. Okay, so different paths we have to take in such a way that only one variable is changing. Accordingly, we have to choose here. So assume this is a sphere, this is the center of that one, it is a sphere. Okay, so from origin we have to move. So from the origin, what we will do in the sense, you take this is z axis, x axis, this is y axis, this is z. So whatever the line I have given here, dotted line, this one, this is actually on the boundary of the sphere only. So when you move from the origin, that means from the center of the sphere to this particular point, okay, you are traveling along the x-axis. Okay, you are traveling along the x-axis from origin to some point on the x-axis. You come up to the boundary of the sphere. From the center of the sphere you have come up to the boundary of the sphere, and you are on the x-axis also. That means charge is moving like that. So this one we can take as path 1. Okay, so from the origin 0, but in spherical coordinates the origin is indicated with 0 comma theta comma phi. Theta and phi values can be given, depends upon the straight line. Okay, on which line you have taken the calculation of the distance. Then this point, if you observe, you are on the surface of the sphere. That means you traveled radius 2 meters. Okay, then you are on the y plane. Okay, this point is there on the xy plane. So on the xy plane theta is pi by 2. Okay, theta is pi by 2 comma phi value we have to give. You are on the xz plane, means phi is started just, that means phi is 0. Okay, then so this is the first path actually. But according to this line, from A to B we have to write theta and phi values for the origin also. So exact center will be like this, 0 comma pi by 2 comma 0. This is the center. Now from the center up to the point B we have to take like this. Okay, this is the path 1. First I will tell you about the paths, then we can go for later calculations, later we can see. So this is the path 1. Next, path 2, if you observe, from B to C we have to go. So B is 2 comma pi by 2 comma 0, that is same. C means again we are on the boundary of the surface, that means boundary on the sphere, that means R is 2 only. Then we are again on the xy plane only, that means theta is pi by 2, but now we are on the y-axis. That means only phi value will be changed. On the x-axis phi is 0, but on the y-axis phi is, by traveling 90 degrees we can come up to y-axis. That means the phi will be changed to pi by 2. So this is path 2. Is it okay? Did you understand C pointer?
Yes, sir.
Okay.
Yes, sir.
Next, path 3. If you observe path 3, they said that last point, that is 2 comma pi by 4 comma pi by 2. So to understand this one, here I am taking, this is z. So if you are here, theta is 0. Theta is measured from the positive z axis. For example, if you take theta is pi by 4, 45 degrees, this right circle cone angle is pi by 4. This side also we have to take. Then in this cone is represented actually by the theta is equal to pi by 4. Because here sphere is there, that sphere will be intersected by the cone. So here you will get one circle like this. So it is not, it is actually in between this y-axis and z-axis, like that we can able to take whenever it is intersecting with that one. So it is the point we can tell. Okay, so when you move like this we can reach that one. That means still we are moving on the surface of the sphere only. The last point D point also available on the surface of the sphere. That means we can take R is 2. Okay, and but theta is reduced now. Theta on the xy plane is pi by 2, but theta is there in the middle. That means it is pi by 4, 45 degrees only. But still we are on the what we can tell yz plane. Xz plane means phi is 0. Then by traveling 90 degrees, you will be reaching this yz plane. Okay, now still the point D is on the yz plane only. That's why this phi value should be pi by 2. This is the point D. So path 3, that is from C to D. If you observe, C point is 2 comma pi by 2 comma pi by 2, and point D is 2 comma pi by 4 comma pi by 2. This is what we have taken. Okay, what is the necessity of taking in this way? There is no necessity to follow these three paths only. Okay, you can go for other paths also. Like first we'll complete this one, then I will tell the another way of doing this one. So these three paths we have started. We have started from origin. Origin is in our case 0 pi by 2 0. Then we are moved the charge finally at 2 comma pi by 4 comma pi by 2. In order to move this one, we have chosen three paths. So in path 1, if you observe, only R is changing. So related DL bar is dr r cap. In path 2, if you observe, R is fixed at 2, theta is fixed at pi by 2, only phi is changing. Okay, so in this case DL bar is whenever phi is changing, what is the scaling factor? R sin theta d phi cap. Okay, next in the third path, R is fixed and phi is fixed, but theta is changing. So when theta is changing, DL bar is equal to R d theta cap. Okay, so what is the necessity of taking in this in these three paths means in each path, if you observe, only one variable is changing, either R or theta or phi. That is the advantage. Okay, if two variables are changing, you have seen in the previous problem, when we have taken the path along the straight line, two variables are involved in the DL bar. That will be difficult to solve. Okay, so if you select the path in such a way, only one variable is changing, then easy to calculate the things. Okay, so in the path 1, you can calculate now E bar or DL bar. In path 2, you can calculate. In path 3 also you can calculate. Okay, one by one we can do that one. So I'm going further. So path 1 I'm doing here. Path 1, we have observed that DL bar is equal to dr r cap. Okay, then E bar dot DL bar is equal to, if you perform here, it is having R component and phi component, so RR will be having the dot product is 1, so phi into e power minus R into dr. Okay, what is the integral? R is changing from 0 to 2. Okay, 0 to 2 only. Okay, E bar dot DL bar, that is equal to 5 times R is changing from 0 to 2 e power minus R dr. So it is 5 times e power minus R, sorry, it is minus R by 4. So and the integration here minus 4 is also required. So limits are 0 to 2. So it is equal to minus 20 times of e power minus 1 by 2 minus 1. And the related work done W1 is equal to minus q times of integral e bar dot dl bar. So minus q means minus 5 micro multiplied with minus 20 e power minus 1 by 2 minus 1. So it is equal to some work you will get. Okay, so in path 2, dl bar is equal to, in path 2 what we have taken, only phi is changing, I think r sin theta d phi cap. Okay, then e bar dot dl bar, e bar is having phi component, that is 10 by r sin theta into r sin theta d phi, r sin theta will be cancelled, so 10 d phi will get. Okay, then integral phi changes from 0 to pi by 2, e bar dot dl bar is equal to 10 pi by 2. That means 5 pi you will get. 5 pi you will get. Then work, exact work is given by minus 2 times of this one is work done 1, this is work done 2. Wt is equal to minus q times of integral e bar dot dl bar. So this is minus 5 micro into 5 pi. You will get some work here. Okay. Then in path 3, if you observe, in path 3 we got dl bar is actually due to the change in theta. That means r d theta theta cap. But fortunately in E bar you don't have theta component. You can see that only R component and phi component you have. So when you perform the dot product with the theta cap, this E bar dot dl bar will be giving 0. That means W3 is 0. So total work done W is equal to W1 plus W2 plus W3 is equal to summation of W1 plus W2. This is around 117 like that you got. Okay, minus 117 or plus 117 joules like that you will get.